Hello and welcome back. Okay, today in this video we're going to look at the 2026 MIT Integration B exam, and here we have an indefinite integral. Yes, everybody knows that feature may be exclusively definite integrals on this channel, but today this problem is interesting enough for me to feature, and it's interesting because it features a particularly interesting algebraic identity. Because at first looking at this problem, you think, okay, maybe something can be done. The problem is that even if you take u equals to s cubed plus 3 plus x, it's difficult to even find the u in terms of the x, because here you get a 3x squared plus 1 dx, and this x squared is now a problem here. On the other hand, even if you take, say, u to be 1 over x minus 1, it's not clear what to do, because though you can find the u and the x, this is very problematic. So instead, what we're going to do is that we're going to see this s cubed and x. How do we get that s cubed and x? Well, to get that s cubed and x, you need a term that contains x to the fourth. So because of the x minus 1 here, it is natural for us to look at and say, okay, let's try and do x minus x plus, say, 1 to the fourth, and let's subtract it from x minus 1 to the fourth. Or maybe we do x minus 1 to the fourth and say we subtract it with s plus 1 to the fourth power, and at least one of them should give us this, but they are both basically the same. So you either get a plus this or minus this. But let's look at this. The first one is going to what we're going to use. So you have if you use the mathrm, this is x to the fourth plus 4s cubed plus after 4, I think you have 6 here, plus 6x squared plus 4x plus 1. I believe so. Yeah, I think it's 14641. Yes. Then you are going to subtract this by still x to the fourth, but now we have to put a minus at the second. So you have minus 4x cubed plus 6x squared minus 4x plus 1. Yes, it's going to be plus 1. So obviously, you have x to the 4, cancel x to the 4, then you end up with what you end up here is 8x to the third. Okay, 8x to the third. And what about this part where they cancel out? And what about here? You end up with 8x. And then what about here cancel out. So now voila, so you have it that, so this is equals to 8s cubed plus x. Now you see the magic here. You see that s cubed plus x is 1/8 of x plus 1 to the fourth minus x minus 1 to the fourth power. So this is 1/8 of this, and though you are never going to be able to see this without experimenting, but that is why integrals are difficult, and that is why they are fun, because we will always experiment. You are always going to look at structures, patterns. But for me, the trick here is that since it's an x to the fourth, since it's an x to the third, you basically think of, let's say, x to the fourth power that can work. Okay, so then you will end up with, so this is our integral here, which is dx divided by x minus 1. So you have the fourth root of s cubed plus x. This is going to equal the integral of dx, and then you have an x minus 1. So you have a fourth root of, now everything here is 1/8. So I'll put that here, 1/8 of x minus x plus 1 to the fourth minus x minus 1 to the fourth power. So that would give you, if you go further, you get fourth root of 8. Okay, 1 over the fourth root of 8 times integral from not integral from 0, but times 1 over, let's say you have an x minus 1, then you're going to factor this out. So you're going to factor x minus 1 to the 4th. So you have the 4th root of x minus 1 to the 4th power. So that would be giving you, you're going to multiply this by x plus 1. So x plus 1 all divided by x minus 1 all to the 4th power minus 1. So everything is under the square root sign dx. So if you go further, we should obtain this is equal to, notice that if this comes out of here, you will have an x minus 1 and x minus 1 together. So you have a 1 over 4th root of 8 times integral of 1 over x minus 1 squared times you have x plus 1 over x minus 1 to the 4th power minus 1. Now, of course, the natural thing to do here is obviously you are going to set t to equal x plus 1 over x minus 1. Now, if we use the so-called what they call it, the so-called quotient rule, you should obtain dt to be at the bottom you have an x minus 1 squared, but at the top you have derivative of x plus 1 is 1 times x minus 1. That is basically x minus 1. Okay, not the way to write it. So that is basically just x minus 1. Then minus, at the bottom you have derivative of x minus 1 is x. So you're going to write this as minus x plus 1. So the x cancel out and you have a minus 2 there. That would be minus 2 over x minus 1 squared dx. Hope I'm correct. Okay. For minus 2. So basically, negative 1 over 2 dt is going to be dx over x minus 1 squared. So we're going to write this as okay, 1 over 4th root of, what is 4th root? Yes, 4th root of 8 times what? Times integral of 1 over okay, this is also the 4th root. The 4th root of t to the 4 minus 1 times negative 1 over to negative 1 over 2 dt. So that would be equals to negative 1 over the 4th root, twice the 4th root of 8 times integral for the t of the 4th root of t to the 4 minus 1. Now we can pull out t to the 4th from this, so you should have, say, negative 1 over 2 times 4th root of 8 times integral. If you pull out t to the 4, you get 1 over t times 1 over the 4th root of 1 minus 1 over t to the 4 power dt. So you can see that we have done a lot to simplify this to this extent by doing all sorts of substitution, pulling out, and the rest. Now it remains for us to, okay, so let me see. So we are going to see if maybe we can find a way to do another substitution as well. So what we're going to do is that we're going to see if we can set t to be 1 over the 4th root of 1 minus 1 over t to the 4th. Here we want to see if we can be able to recover dt, we want to see if we can be able to recover dt over t. So let's start with that, okay? So here what we do is that we will set u here. U would equal, let's say, 1 minus 1 over t to the 4th to the 1 over 4. So basically u to the fourth would be 1 minus 1 over t to the fourth power. Okay, so now we can find let's see, how do we even go about this? Okay, that means 4u to the third power du would be equal to, so derivative of 1 is 0, so you have a negative of t to the 8th power, then at the top you get a 0, but at the bottom part you get a minus 4 times t to the third power, so you get a 4 divided by t to the 5th power dt. So basically you would have dt, so this means that dt over t would be equal to t to the fourth power, t to the fourth power times u cubed du. Okay, practice that, because here you have a dt over t to the fifth, so we took a t to the fourth power, multiply both sides, so dt over t, so we're looking for dt over t is equal to t to the fourth times u cubed. Now let's see if we can put in terms of u. What is t to the fourth power? Well, here t to the fourth power here is basically, so because you have 1 over t to the fourth power equals to 1 minus u to the fourth power, so t to the fourth power here is 1 over 1 minus u to the fourth power. So basically you would have a u cubed divided by 1 minus u to the fourth power du. So now, which is good for us, because since we set all of this to be u, okay, we are able to find dt over t in terms of du. So basically this will continue as follows. You would have the integral of is this a minus or positive? Okay, negative 1 over 2 to the fourth power, right? Okay, no, 2 times the 4th root of, the 4th root of 8 can be simplified, but let's not just bother with that for now. 4th root of 8 times the integral of, so we have 1 over t dt, which is going to be okay, first of all you have 1 over t dt, so that would be du, so that would be u cubed du, all divided by 1 minus u to the fourth power. Then you would have, what about t? You have a 1 over u, right? Yes, this will be u is, this is 1 over u, yeah, this is 1 over u, so that is multiplied by 1 over u. So we would have negative 1 over 2 times the 4th root of, okay, that is 4th root of 8, 4th root of 8. Then you have the integral of u squared all divided by 1 minus u to the fourth power du. So I think we can do some partial fractions here. You have a negative 1 over 2 4th root of 8 times the integral of, you can have u squared over 1 minus u squared and 1 plus u squared, so du. And if you do the partial fraction representation, I think you can do let me see, 1 over 1 minus u squared plus 1 over 1 plus u squared, so that is, you're going to have, okay, no, it's going to be a minus, so you have 1 plus u squared minus 1 minus u squared, so you will have they cancel out, and then you have 2u squared over 1 minus u squared 1 plus, so you have to divide both sides by 2, which means that this 2 will vanish. Okay, yes, which means that this 2 would vanish. No, you have to divide both sides by 2. Okay, that means we're going to get 4 here, rather. So you're going to get negative 1 over 4 times the 4th root of 8. Then you have the integral of 1 over 1 minus u squared minus 1 over 1 plus u squared du. Okay, so basically now we will end up with negative 1 over 4 times the 4th root of 8 times, yeah, this is tan inverse, right? If you remember, let me check. If you remember your standard integral tables, you should get that. So let's see. That is yeah, this is tan inverse. So this is basically tan, that is hyperbolic tan inverse of u. Then this one is subtracted by the tan, just the tan inverse of u. Okay, now we have a plus c. So what we're going to do is that we're going to write this as tan. Okay, this is 4 times 4. So this is 4 is 2 to the second power times 4 to the 8 is 2 to the third power divided by 4. So this will be 4 times 2, 8 plus 3, 2 to the 11 fifth, right? 2 to the negative 2 to the 4 times 2, 8 plus 3, that is 11. So this is 11 over 4. Let's just forget it though. This is negative 1 over, this is positive 1 over 4 times the 4th root of 8 times the tan inverse of u, and then plus the hyperbolic tan inverse is 1 over 2 times the logarithm of 1 plus u, right? Yeah, 1 plus u, all divided by 1 minus u, then plus c. So if you plug in your u and then plug in your t, you are going to get the form. So I'm going to write down the final form. The final form of this answer is 1 over 2 times the 4th root of 2 times the tan inverse of the 4th root of 8 s cubed plus 3 plus x rather. Then you would have divided by x plus 1. Then you have minus 1 over 2 square root 2 times the logarithm of, there's a very long logarithmic form, so you have an x plus 1, and then you have the 4th root of plus the 4th root of 8 s cubed plus x, and then the same thing, but then you have an x minus 1, and then plus the 4th root of 8 s cubed plus x, and you will get all of this if you plug in u and then plug in t again, so that you can obtain the value of x. So you can see that this is a very long process, very involved, and a lot of manipulations are done here, but I really enjoyed myself solving this problem. Please do subscribe to the channel, please, and turn the notification on so that we can get more videos I make. Okay, thank you very much, and please do have a nice day.